In this video, we'll talk about monotone functions, what they are, and how we can think of them as another application of the mean value theorem. What do we mean by monotone functions? Well, basically, monotone voice means someone's always talking at the same pitch. Monotone functions are always doing sort of the same thing. Right? In this case, they're always increasing or always decreasing. That's what we mean by monotone functions. So for some definitions here, we say a function f is increasing on some interval from a to b if, whenever I pick 2 points in this interval, if at the bigger point my function is bigger. So if for any x and y in this interval, with x less than y, we have that f of x is less than f of y. How can you think about this? Well, this basically means that as I go to the right, as I take bigger input values, my outputs get bigger. This means I'm sort of increasing as I move to the right, hence the term increasing. We have a similar definition for function being decreasing, in that now it just goes the other way. Where in this case, now my function gets smaller as I go to the right. If I take bigger input values, I get smaller output values. And a function that's either increasing or decreasing on an interval is called a monotone function. Now note, this fact means that it can only be increasing or only be decreasing. If it does both at different points, it's not a monotone function. A monotone function means it's always increasing or it's always decreasing on the entire set where it's defined. If it does both, it's not monotone. So how can we figure out if a function is a monotone function? Well, the point here is the mean value theorem. Right? This would be a really hard condition to check by itself, right? It requires for every x and y with x bigger than y have a certain property hold. That's a lot of things to check. However, the mean value theorem helps a lot here. The point being, there's my result for the mean value theorem. If I know that y is bigger than x, then this here is always positive. So if I want to figure out if f of y is bigger than f of x, that means I get a condition on whether this is positive or negative, which I can relate to how the derivative behaves. And that's why this helps us out here. The result we really get is the following. Let f be a differentiable function on an interval from a to b. Then, if f prime of x is positive on this interval, then f is increasing on that interval. On the other hand, if it's always negative, the derivative is always negative, then the function is decreasing. And why does this work? Well, the argument's the same as above. If I assume that f prime is positive, and I take any x and y in a, b with x less than y, then by the mean value theorem, f prime at some point c, which is between x and y, is equal to f of y minus f of x over y minus x, or f prime at that point c times y minus x equals f of y minus f of x. Now, we know that f prime is positive by assumption, and we also know that because x is less than y, this is also positive. Therefore, their product is also positive, which means that f of y minus f of x is greater than 0, which is exactly what I wanted to show, because then f of y is bigger than f of x, therefore f is increasing. And the same argument works for the decreasing case. So what does this get us? Well, this lets us talk about a variety of functions and whether they're increasing or decreasing directly without having to think about the actual graph or how they behave on certain points. So I want to show that 1 over x is a decreasing function on 0 to infinity. I'll get that by taking the derivative. So the derivative of this, f prime of x here, is negative 1 over x squared, which is always negative. Therefore, by the statement above, this means this must be a decreasing function. I mean, we kind of already knew this fact, right? This is a pretty easy fact just by knowing what the function does. 1 over a bigger number is smaller. And that's sort of the same thing with having a positive and negative slope, meaning you're increasing and decreasing respectively. That's also a pretty simple fact to visualize. Positive slope means I'm increasing, negative slope means I'm decreasing. But now we have an actual proof and a way to actually use this fact directly, just using calculus. Another way you can use this is to figure out where a certain function is increasing or decreasing. This basically means I'm going to look at the derivative and figure out where the derivative is positive or negative, and use that to tell me where this function is going to be increasing or decreasing. So to do that, let's first take the derivative. this case is going to be 3x squared minus 6x minus 9. Now to find where this is positive and negative, we're going to look at places where it's 0, because that's where it could change from being positive and negative. So we're going to set this to 0 and solve. We'd also want to look for points where it doesn't exist, but in this case it's a polynomial, so that doesn't happen. I can divide through by 3, and this here factors as x minus 3, x plus 1. So the points where the derivative crosses 0, i.e. my critical points, are at 3 and minus 1. To wrap this up, the first thing we draw is a number line here. We know this function is 0 at minus 1 and at 3. And I want to figure out what happens in between, because that will tell me whether things are positive or negative, or whether they're increasing or decreasing. So if I plug in 0 to this function, I will get a negative 3 times 1, I'll get a minus sign. If I plug in negative 2, I'll get a plus, and I'll get a plus over here. This is for my derivative f prime. I'm plugging values into here to make this happen. And what does this tell me? Well, this tells me my function is increasing where the derivative is positive. So f of x is increasing on two intervals, the part below minus 1 and the part above 3. So it's increasing on minus infinity up to minus 1 and on 3 to infinity. And similarly, f is decreasing on this middle part from minus 1 up to 3. That's what we can talk about increasing and decreasing functions and monotone functions in general using the mean value theorem, and use it to determine where a certain function is increasing and decreasing.